For the true or false questions. Question 1. Every polynomial with an even degree has n behavior up, up. It's easy to disprove this because we can come up with a simple counterexample that shows that this is not always the case. This is f of x equals negative x squared. It has an even degree, but its n behavior is down, down. Question 2. A polynomial of degree 5 always has at least one real zero. This is true. In class, we saw an example of cubic functions. Cubic functions, or functions of degree 3, always have at least one real zero. This is because odd-numbered functions, odd-degreed functions, will either be down, up, or up, down. Those are the only two options. If they're either down, up, or up, down, that means at some point they must cross the x-axis. There is no line, horizontal line, that you can draw that they will always stay above or below. They will go through every possible y value. So this is true. Every odd degree polynomial must have at least one real zero. Question 3. If a polynomial p of x is divisible by x plus 7, then p of 7 equals 0. This is almost correct, however, it is not correct. According to the factor theorem, if a polynomial is divisible by x minus a, then a, when it's used as an input to that function, produces a 0. So in other words, if a polynomial is divisible by x minus a, then p of a equals 0. However, in this case, a must be negative 7, because the binomial that it is divisible by is x plus 7. So in this case, our a value is negative 7. So the correct statement would be p of negative 7 equals 0. Next question. If a polynomial p of x is divisible by x plus 5, then p of 0 equals 5. This is not true. As above, the correct statement would be that p of negative 5 equals 0. We can conclude that p of negative 5 equals 0. That does not mean that p of 0 is necessarily equal to 5. It doesn't prove that p of 0 is not equal to 5. It just means we can't assume that p of 0 equals 5. But we can assume that p of negative 5 is equal to 0.